Now we will understand how to refine the mesh. Now we have lots of options that we will be studying. As we discussed, we will be studying the global mesh settings and the local mesh settings. So one of the settings that we need to study under the global mesh settings is relevance. First, let us understand what relevance is, and then we will see how to use this relevance in meshing. After generating a mesh for your model, you can increase the number of elements using this relevance option. Okay, the relevance option is available in the details of mesh, and it allows you to control the fineness of the mesh for the entire model. So whenever you use the relevance option, it will control the fineness or coarseness of your mesh for the entire model. It cannot be applied to one single surface or an edge. It will happen on the entire model. That is why it is called as a global mesh setting. The default relevance value is set at 0. If you see this image over here, you can see their relevance is available in the details of mesh. By default, the relevance is always set to 0, but we can change the relevance by specifying a value over there, and it can change from -100. You can drag the scroller to the negative side or to the positive side. Okay. Now, as we are moving from -100 to +100, you are increasing the number of elements. That means -100 gives you a coarse mesh and +100 gives you a fine mesh. You can see 3 images over here. This is one image where the relevance is set to 0. So I have got this meshing. Next, if I change the relevance setting to +100, it becomes finer. And when we change the relevance setting to -100, this is the coarse meshing that we got. Okay. Now let us see how to use the relevance in Ansys Workbench. Okay, so by default the relevance is set to 0. Okay, so when the relevance is set to 0, this is the default mesh setting that I am getting. Okay, after that, if we change the relevance at 0, the number of nodes that we have got and the number of elements that we have got is 2595 number of elements. If we change the relevance setting to -100, now as we discussed in the PPT, if we change it to -100, it will become a coarse meshing. Okay, so the element number has reduced, and if we perform the analysis at 0, when the relevance value was 0, we had got the answer as 4.7. Now if we see, look at the answer, look at the result. Okay, so we understand that with coarse meshing, the answer is also becoming very approximate. It is not towards accuracy. Now, if we make it finer, if I change my scroll to +100, it will become very, very fine. And the number of elements will also increase. So now the number of elements have increased to 4819. And the answer will also become accurate. Okay, so you can see over here the answer becomes much. If I still make it finer from here, your answer will still improve. Okay, so what is the meaning of relevance option is, you can change the scroller over here from -100 to +100 to refine the mesh, and this is one of the global settings that we have, which can be used for refining the mesh on the entire model. We have seen some examples over here, the same we have also performed. Okay. Now, how do you decide what is the optimum mesh size for your analysis? Okay. Now, it is very difficult to understand what should be the optimum mesh size, what should be the effective mesh size for my analysis. So, when we are performing an analysis, if we refine the mesh, or if we keep on refining the mesh, your answer will become much more accurate. But as we are refining the mesh, what happens is the time taken for the analysis also increases. Okay, so as a design engineer, we need to keep a balance between the time required and the accuracy. Okay, in some cases, if it is a very complex model where time is not the primary constraint but accuracy is, means if we want much more accurate results, then in that case you can refine the mesh till you get an accurate answer. Okay, but in some cases where time is important, in that case you can have in between mesh means you can keep the refinement at zero and you can get an answer. So it is very, very important to keep a balance between the time and the accuracy. Okay, now let us understand this. We will take the same example. Now the refinement, we have achieved the maximum refinement, but still from here, if I still want to refine it much more, okay, now what we can do is we can give an element size over here. Currently it is a default element size, means the element size is being decided by the relevance value. Okay, but now if you want to give your size, if you want to assign a element size, you can assign it over here. Okay, now when you assign the element size, you will see one scroller over here. Along with the scroll, you will see one circle. If you see, you can see one sphere in the center of your cursor. That shows you what is the element size going to be. Okay, so now see, if I increase it to 3, your sphere also increases and it shows what is going to be the element size. So now from this side, if you see, 3 is very, very small. So let me change it to 10, okay, or maybe 12. Okay, so I will say that I want the element size to be 12 and I will remesh my model. So now the element size is going to be 12 or lesser than that because the refinement is at 100. Now the number of elements from 4819, it has increased to 13,277. After which, if I solve my analysis again, previously your answer was somewhere around 5.2. Now if we see, the answer will increase. So now you can see that it has become 6.05. So from 5.2, now it has become 6.05. If we still mesh it further, refine it, let me make it as 10. I am reducing the mesh size, that means I am increasing the elements, so that my answer becomes much more accurate. Okay, so now the number of elements has increased to 18,571. Let us have a look at the answer now. You can see that the run time is increasing now. The time taken for the analysis is increasing. Okay, so the answer is 6.16. Now if you see, slowly the answer is becoming constant. It is moving towards constant. That means if we draw a graph, okay, here let us say, so you will see that the graph changes like this. Okay, you will see that the result, the analysis result that you have over here, okay, it will become constant after a certain point. Here you have the number of elements. So as the number of elements are increasing, you will see that your answer is also becoming much more accurate. But after a certain point, you will see that, so we can understand over here that as the number of elements increase, the accuracy of the analysis also increases, but after a certain point you will see that it becomes almost constant. So from this graph, or from this, you can decide what should be the optimum mesh size. Okay, you need to keep a balance between the time and the accuracy. Okay, so this is what we are trying to discuss over here, that you need to maintain a balance between the time taken and accuracy, and this understanding will only come after some time, means after you have spent some time in FEA analysis and everything. Okay, so this will come according to experience and according to the use of software.